Hello, everyone. This is lab number 5, and this will be going over the motion of a falling object with initial velocity. So, the purpose of this lab is to observe the motion of a falling object with initial velocity. We're going to create two models based on this observation. One model is going to include only the force of gravity, and the other model is going to include the force of gravity as well as the drag force. Comparing the data from the experimental data as well as the two models. And also, we're going to come to a conclusion based on the observations that we made throughout this lab. So, with conducting this experiment, what I did is I threw an iPhone 13 into the air and let it fall to the ground. And when I did that, I used Tracker to track the position of the iPhone at every frame. And those are the positions in the bottom right corner. And once I got done conducting that experiment, I took the data from the first time and the second time of the frames, and I calculated its velocity. So right here, I have position 1 and position 2, and my delta t is going to be 0.033 seconds. And in order to calculate velocity, I took the final position and I subtracted it from the initial position, and I divided it by delta t. And once I did those calculations, I came up with an initial velocity of 2.68 meters per second. So once I did all of that, that's when I started coding. Now, the mass of the iPhone is 0.17 kilograms, and the initial position of the iPhone is seen right there, and that's the initial velocity on the next line, as I calculated on the previous slide. And the initial time is at 0, and my delta t, as seen before, is 0.033 seconds. And we include the force of gravity, which is 9.8. And for this snippet of code, this is without drag. So we're going to have no air resistance. So we set B equal to 0. And this is the rest of the code. As you can see, B is 0 because we're not using drag. Work is going to be negative ball.m times G times J hat. And F net is just going to be W because there's no drag force. And we use the momentum principle, otherwise known as Newton's second law, to update the object's velocity and the object's position. As you can see, the position is the position plus the velocity times delta t, and the velocity is the velocity plus F net over the mass of the iPhone times delta t. And these are the code snippets with the drag. The only difference is we included a drag force, which is negative B times the velocity of the ball. And instead of just W being the net force, now it's going to be W plus the drag force. And in this case, B is set to be 0.05. So once we compare all of the data, we see a slight correlation in all of the graphs, well, all of the lines. The model with drag, without drag, and the experiment, as we can see, there's a slight difference with and without drag as expected, but they all follow the same trend. Okay, for our conclusion, the model with drag predicts a terminal velocity, which is when the falling object is no longer accelerating. And if the object was thrown downward, then the terminal velocity would not be the same as the thrown object would have a higher initial velocity than the object dropped from rest. But in this case, we threw it up and then we let the iPhone fall down, which gave us different results. And that's the conclusion of my lab.